Now we are ready to talk about frequency and probability functions. So, a relative frequency function is the number of observations n sub I in the interval I covering the range x sub I minus delta x to x sub I divided by the total number of observations n. This is basically just getting the number of observations in a given interval divided by the total number of observations. You already know what is a relative frequency from your statistics, and this is not different. Okay, relative frequency is just the ratio of the total number of observations in that interval divided by the total number of observations. Okay, so we have f of x sub I is just equal to ni over n. This s right here indicates that this is coming from our sample. Okay, sample. On the other hand, we also have the cumulative frequency function. The cumulative frequency function fs of x is the sum of the values relative frequencies up to a given point. Basically, this is just the sum of the relative frequencies up to that interval below. Okay, so we just need to sum the relative frequencies in this case. So this is for discrete. Okay, this is for the discrete. I mean, we'll take a look at this one in our example later on. Okay, we also have the probability density function. Remember, we have the relative frequency function. We also have the probability density function. Okay, this probability density function is for the population already. Okay, this is for the population already. As for the relative frequency function, this is for the sample. Okay, but for the probability density function, this is now for our population. Okay, as you can see, we have now f of x, and we do not have any subscript s anymore. Okay, this is the limit of the relative frequency. As you can see right here, this is the relative frequency as delta x approaches 0, meaning we want to get the relative frequency as the interval, the limit between those intervals, or the gap between those intervals is relatively 0, meaning this is now a continuous functions or continuous function. The same is true for the probability distribution function. This is now just the same as the cumulative frequency function, but in this case we have a continuous function. Okay, we have a continuous function. The limit of the cumulative frequency function as delta x approaches 0. All right, so let us take a look at the relationship between the probability distribution function and the probability density function. Remember, the probability density function is the relative frequency. Okay, remember that the probability density function is the relative frequency, while the probability distribution function is the summation of the relative frequencies, because we have the big F right there. Okay, the relationship is just the derivative and the integral. So the derivative of the probability distribution function is the probability density function. So if we want to get the probability density function, we just need to get the derivative of the probability distribution function. On the other hand, if you want to get the probability distribution function, we just need to take the integral of the probability density function. All right, so that's just the mathematical relationship between the two. All right, now our problem in hydrology is to distribute the hydrological data into probability distribution functions. Okay, it has already been agreed upon by hydrologists and engineers that precipitation can be modeled using various probability distribution function. Okay, and what you can see in the table right now are the different probability distribution functions commonly used in precipitation. Okay, so we have the normal distribution. You have already discussed the normal distribution in your statistics class. We also have the log normal. Basically, the normal and the log normal are the same. The only difference right here is we just change our values of x in the normal by the logarithm of x. Okay, we also have the exponential, and we also have the extreme value type of type 1. This is also called the Gumbel distribution. And as you can see right here, the parameter that we need to solve for the normal distribution is the mu or x bar, and the sigma or the s. This one, the mu is the mean of the data, and the sigma or s is just the standard deviation. You also know how to compute for the mean and the standard deviation of your data. Okay, basically for exponential, the lambda is just equal to 1 divided by the mean x bar. X bar is for the mean. For the extreme value type 1 or the Gumbel distribution, we have alpha and mu. Alpha is just equal to the square root of 6 times the standard deviation divided by pi. So basically, we just need the standard deviation. For mu, we have x bar. X bar is the mean of the data minus 0.5772 times alpha. Okay, so basically, for extreme value type 1 or Gumbel distribution, we only need the standard deviation and the mean as well. Okay, so these are the probability distributions for fitting precipitations. We in other hydrologic data, sa iba, hindi lang sa precipitation, marami pa tayong ginagamit ng probability distribution. Hindi lang itong apat na to. But these four are the most commonly used in precipitation. Okay? So, ang pinaka gamit dito by hydrologists is the Gumbel distribution, the extreme value type 1. Okay? So we are going to basically use the extreme value type 1 or the Gumbel distribution in fitting hydrologic data. Let us take a look at this one. So fit the following precipitation data into a normal, log normal distribution, and Gumbel distribution. Okay, let us take a look at first the normal distribution. This is the same data we have from our previous example. Okay, the first thing that we need to do if we are given ungrouped data, something like this, we need to create a frequency distribution table. Okay, that's our first step. The frequency distribution table. Okay. Creating the frequency distribution table is easy, right? Because you have already done this in your statistics class. Okay, paano gawin itong frequency distribution table? Una, the first step is to look for the minimum and the maximum data. Minimum and the maximum data. So what is our minimum data right here? So our minimum data, if you arrange the data from lowest to greatest, we have. Now to do this, it is easier for us to use the Excel. Okay, so I hope every one of you has Excel in your computers. Okay, so I have already encoded the data in Excel from 1910 to 1979 right there. Okay, so what I'm going to do is to go to data and sort. Okay, I'm going to sort this, and then I have to check my data has headers, and I'm going to sort the column by precipitation, smallest to largest. Okay, so I have here the minimum is 16.8, so we have 16.8. The minimum is 16.8, and the maximum is 61.7. Okay, So the maximum is 61.7. Okay, I have now the minimum and the maximum values of the given data. Now to create the frequency distribution table, I have to create my classes. Okay, so the classes, we have a formula for the number of classes. Okay, number of classes. The number of classes is given by our formula 1 plus 3.3 logarithm of n. Okay, so the number of classes is equal to 1 plus 3.3 logarithm of n. Okay, so in this case we have the number of classes is 1 plus 3.3 times logarithm of 69. Okay, we have 69 data, so 1 plus 3.3 logarithm of 69 is just equal to, of course, for the number of classes, this one should be a whole number. Okay, dapat whole number siya. So if it's in decimal form, we need to round up. Okay, let us take a look. Let us note in here, we have to round up. Okay, if this is 7 point something, we are going to round this up, so we have 8. Okay, so our number of classes should be equal to 8. Alright, okay, now we are decided that our number of classes should be equal to 8. Now our next step is to solve for the class width. Okay, so the class width, our third step is to solve for the class width. Okay, so for the class width, this is just equal to the maximum minus the minimum, or basically the range. Okay, maximum minus minimum is the range divided by the total number of classes. So this one basically is 61.7 minus 16.8 divided by 8. Okay, so if we try to compute this and round this to okay, since our data, our original data, if you take a look at this one, our original data is rounded off to 1 decimal place, di ba? 1 decimal place lang yung data natin. So the class width, itong class width natin should be rounded off to 1 decimal place as well. Okay, ito, ang pag-round natin dito sa class width should always round up. Okay, it should always round up. Kagaya ng ginawa natin dito sa number of classes, we rounded the number of classes up. Itong class width, round up din. Okay, so if we try to compute the class width, the class width is just equal to 5.61. So if we round this up to 1 decimal place, we have 5.7. Okay, so we have 5.7. We need to take note in here that we need to round up. Okay, the number of decimal places should be the same with our original data. Okay, paano kung iba-iba yung number of decimal places ng data natin? Yung kung ano yung pinakamaraming number of decimal place, doon na lang tayo. Okay? So, since pare-parehas naman na 1 decimal place lahat yung data natin, so we are rounding this up to 1 decimal place. Now, we are ready to create our frequency distribution table. Okay, frequency distribution table. Paano na? So, ang unang gagawin natin is the minimum, yung pag-compute ng lower bound. Okay, ganito yung table natin. The lower bound is, itong first na lower bound natin is just the minimum. Okay, ang minimum natin ay 16.8. So, our first lower bound is 16.8. Alright, so 16.8 yung first lower bound natin. And then, we need to compute for the lower bound of the next classes, itong mga intervals natin. So, we can get the lower bound of the next interval by adding the first lower bound and the class width. Okay, so basically, itong next na lower bound natin ay 16.8 plus 5.7. So, if we have 16.8 plus 5.7, we have 22.5. Okay, so our next lower bound is 22.5. And then we add 5.7 again. We have 28.2. And then plus 5.7, we just need to add the class width to get the next lower bound. Okay, we just need to add 5.7 to go to the next lower bound. And then plus 5.7, we have 45.3. And then plus 5.7, we have 51.0. And then 5.7, we have 56.7. And then we just need to, since we only have 8 classes lang yung na-compute natin, di ba? Mag-add lang tayo ng isang extra class dito sa baba. Okay, we just need to add another 5.7. We have 62.4. Okay? And then for the upper bound, itong upper bound natin, ang pag-compute dito sa upper bound is just subtracting from the next lower bound, di ba? Ang susunod ng lower bound natin ay 22.5. So, since this is rounded off to 1 decimal place, mag-subtract lang tayo ng 0.1. Okay, so basically this is 22.4. Okay, that's 22.5 minus 0.1. So we have 22.4. We do the same. So this is 28.1. This is 33.8. This is 39.5. This is 45.2. This is 49.9. This is 50.9. Sorry. 50.9. This is 56.6. And then 62.3. Okay, those are our upper bound. So basically, ang mangyayari na dito, the lower bound and the upper bound are our limits to compute or to solve for the frequency. Okay? So itong frequency natin, the frequency is just coming from our data. So how many data do we have from 16.8 to 22.4? Magbibilang na tayo ngayon from our given data. So we have from 16.8 to 22.4. So bilangin na natin kung ilan yung 16.8 to 22.4 dito. And we should come up with, magbibilang ako, okay? You do the same. Magbilang kayo. And we should come up with the same answer later on. I-pause ko muna yung video. Okay, so I have come up with the following frequencies. Nandito na. Okay, from 16.8 to 22.4, I have 2. From 22.5 to 28.1, I have 4. From 28.2 to 33.8, I have 12. From 33.9 to 39.5, I have 15, and so on. Okay, if we take a look at the last row, the total row should be equal to 69, right? Because we have 69 total number of observation. Okay, let us go to the next column. Itong next na column natin is the relative frequency. Okay, relative frequency, or relative frequency function. This is f sub s of x sub I. X sub I meaning the interval. Okay, so let us go back to our table and name this as the relative frequency function, or we can just type in f sub s of x sub I. Okay, this is our relative frequency function. So this is just the ratio of the frequency divided by the total number. Okay, so this is basically 2 over 69. Okay, so 2 over 69 2 over 69, or this is equal to, in decimal, this is 0.0290. So to 4 decimal places, for 0.0290. Okay, so we do the same for the remaining intervals. We have, this is like 4 over 69, 12 over 69, 15 over 69, and so on. Okay, we do the same for every row. And then we should come up with the following values. Ito. Okay, and take note that the total should be approximately equal to 1.000, because the total number of probabilities should be equal to 1. Okay, so that's the total number of probabilities. Okay, for our next column, we have the other one, the cumulative frequency function. Okay, the cumulative frequency function is just the sum of the relative frequencies up to the given point. So basically, ito, pangalanan natin F sub S and then X sub I. Okay, this is just the sum of the relative frequencies. So ito, since wala pa siyang before this, wala pa, so the sum is just 0.0290. For the next interval, this is now the sum of the two previous relative frequencies. Okay, so that's 0.0290 plus 0.0580. That's 0.0870. Okay, this is the sum. Okay, etong column na to, I mean cell na ito, this is the sum of these two. Okay, to come up with 0.0870. Okay, dito sa pangatlo, this is now the sum of the three. Itong pang-apat, sum of the first four, and so on. Okay, and in the end, itong last na, okay, gawin natin, okay? Gawin natin to get the sum of the previous relative frequencies up to that point. Now, we should come up with the following numbers. Okay, eto na. Take note dito sa huli, since we are now taking the sum of all the probabilities from all the intervals, so ang sum na ay dapat 1.0. Okay, yan na yung cumulative frequency distribution. Okay, now we are going to insert two more column. Okay, gawin natin itong 2 more columns. So let us insert to the right ng dalawa. Okay. Then gawin nating maliit. Alright, so meron na tayong nito. Dito na natin itong cumulative, wala ng S, f of x, at dito yung sa f of x na maliit. Okay, itong una, this is our probability distribution. Okay, this is our probability distribution. Dito na nagkakaiba-iba, depende kung anong distribution ang gagawin mo. Okay, una, pwede dito the normal distribution. Kung normal distribution ito, gagawin natin yung normal. Ito. Okay, gagawin natin itong normal probability density function. Okay, and since gumagamit tayo ng Excel, meron ng function ang Excel. Hindi na natin mahirap ito, di ba? Mahirap gawin ito kasi medyo mahaba yung kanyang equation. But since we have Excel, magagamit na natin ang Excel dito. Okay? So let us go back to our Excel file. Kokopyahin ko na itong nagawa natin na table and i-continue natin sa Excel. Ito, Okay, so let us go to Excel. Okay, so nandito na tayo sa Excel. Although hindi na siya sa 4 decimal place, itong FS taka F, ito. Okay, so ang nagkakaintindihan naman tayo dyan. Okay. Okay, so ang gagawin natin dito sa Excel, if you punta muna tayo sa concept, balik tayo sa concept nito. Okay, a normal probability distribution, normal muna tayo, a normal probability distribution is a bell-shaped function. So ang itsura niyan, parang bell shape siya, ganyan. Okay, so the mean nandito sa gitna. This is the mean. Okay? So, symmetrical ito. Di ba? From your statistics, symmetrical ito. From -1 to +1. So, nandito yung mga number of standard deviations from the mean. Okay, naalala nyo? Ito. Okay, itong sa, kasi, ang gagawin natin dito sa Excel, mamaya, we are going to compute for the cumulative frequency distribution. Okay? So, ang gagamitin natin, if we go back to our table, ang gagamitin natin ay upper bound, itong 22.4. Okay? So, if we use the 22.4 for our data, for example, dito, kung nandito yung 22.4, for example, nandito yung 22.4. Siyempre, below the mean yun, 22.4. Iko-compute natin itong area na ito. Okay? Iko-compute natin yung area na yan. Yan yung gagawin natin sa Excel. At kung gagawin natin, for example, yung from 22.5 to 28.1, for example, yung sa normal distribution natin ay nandito yan, between ito tsaka ito. Ito yung area na kino-compute natin. Ang sa Excel kasi, ang i-compute niya yung area from dito papunta to the left, and then ima-minus natin ito minus yung area to the left. So matitira yung area na ito. Okay? Ganun yung gagawin natin in this case. Alright, so let us go back to Excel. Okay, ang gagamitin natin ay yung upper bound, 22.4. Pero bago yan, ang kailangan natin kasi to compute for the normal ay yung mean and standard deviation. Na-compute na natin yon, okay? So, the mean and standard deviation ay nandito na. I-ano ko na lang dito sa baba. Okay? So, nandito na yung mean. Itong mean galing doon sa data natin na 69 data. Ang sa pag-compute sa Excel, lang average equals average, tapos select lang natin yung buong data. Okay, for example, nandito yung data natin, Nandyan yung data natin. Wait lang, hindi ko pa na. Okay, nandito yung data natin. This is the year, that is the precipitation. So yung pag-compute ng mean is just equal average. Ayan, average. Tapos i-click lang natin yung data. And then enter. So yan na yung mean. Yung standard deviation naman, ST. Yan, ST dev. Tapos mayroong dalawa, P and S. Ang gagamitin natin yung S because these data are considered samples. Okay, so S yung gagamitin natin, and then let's select the data and then enter. So nandyan na yung standard deviation. So ito yung mean, ito yung standard deviation. I-kopya natin doon sa data natin. So nandyan na. This is our mean, this is our standard deviation. So yan, kompleto na tayo ng ating data. So we can now compute for the cumulative distribution function using the normal distribution. Okay? Ang gagawin lang natin is equals to normal. Okay? Makikita ninyo dyan maraming normal. Okay? Ang gagamitin natin ay your normal distribution. Okay? Norm.dist. Okay? Norm.dist yan. And then, ang kailangan natin ay X, mean, standard deviation, tsaka cumulative. Itong X, ang isa-select natin for X ay yung upper bound. So, itong 22.4. And then, comma, the mean, na-compute na natin yung mean, yan, i-select lang natin yung mean na ito, and then comma, standard deviation, i-select lang natin yung standard deviation, and then cumulative true. Okay, cumulative is true. And then close parenthesis and then equals. Ito na ngayon yung probability less than 22.4. Okay, this is now the probability less than 22.4. Okay, lahat ng less than 22.4, ito na yung kanyang probability. Okay, we do the same, but this time, ang gagawin natin dito is now the 28.1. Okay, so the 28.1, the same procedure. Or pwede din, okay, the same procedure muna, norm this. Okay, itong una. norm.dist. X is the upper bound, that is 28.1, and then comma, the mean, comma, is standard deviation, and then cumulative is true, and then enter. So yan na yung kanyang probability, the probability less than 28.1. Okay, that is the probability less than 28.1. We do the same. We can just drop this down, pwede, pero ayaw natin na mag-move itong mean and standard deviation. Ang gusto lang natin mag-move is itong C3 na to, okay? So ang gagawin natin, lagyan natin ng $sign yung mean and standard deviation. Punta tayo dito sa mean, lagyan natin ng $sign, and then the standard deviation, lagyan natin ng $sign. Okay, and then enter. O pwede na nating hilain ito pababa. Hindi na mag-move yung mean and standard deviation natin. Okay, you can check kung tama C6, C7, C8. Tingnan niyo hindi na nag-move yung D11 and D12. So yan na yung cumulative frequency distribution natin. Now our next column is the probability distribution function. Ito na yung hinahanap na lang natin from 16.8 to 22.4. So, since ito, parehas lang siya, ganyan lang, equals lang siya. Itong susunod na to is just the difference between these two. Okay? Kasi ang tinitignan na lang natin dito is from 22.5 to 28.1. To do that, i-minus lang natin ito minus this one. Okay, we do the same. Ito, i-minus natin itong 20.2591. I-minus natin itong 0.1032. Okay, so ito minus ito. Right? Okay. So we do the same. Pare-parehas lang yan. Meaning we can drop that down. Okay, kung titignan ninyo dito sa f of x, di ba 0.99267? This is the probability less than 62.3. So, hindi siya equal to 1. Ibig sabihin, meron pang natitirang 0.00 something dito, greater than 62.3. Okay? So, yung natitirang probability na from 1, yun na yung probability na greater than 62.3. Okay. So, yan na. Na-fit na natin itong f of x. Pwede na natin itong kopyahin. Okay, since we use 4 decimal places, gawin natin 4 decimal places ito para makopya doon sa table natin na nagawa natin sa PowerPoint. Okay? Punta tayo sa PowerPoint natin. Punta tayo sa PowerPoint. Yan. And then, i-copy paste natin yung galing sa Excel. Paano ba to? Yan. Okay. Gawin lang nating 18 ito. Alright. So, nandyan na yung ating f of x tsaka f of x. So, basically, dito sa mga fitting problems natin, ang nagbabago lang actually ay itong dalawang last column natin. Is 2 last column. Alright? So, paano natin ma-check kung okay na gamitin ang normal distribution o hindi? Okay? Paano natin ma-check na okay, na-fit na natin siya sa normal distribution. Now, pwede kayang gamitin ang normal distribution o hindi? Okay, so to do that, we are going to use the chi-square test. Okay, from your probability or statistics and probability, magkakaroon tayo ng chi-square test. So magkakaroon ulit tayo ng another column. So balik ulit tayo sa Excel. Gagawa tayo ng chi-square test. Okay, so dito na, last column natin is the chi-square. Okay. So nandyan na, nakikita ninyo, ano ko lang. Yan. Yan. So this is now our column for the chi-square. So sa chi-square, ano lang, meron tayong formula for chi-square. The formula for chi-square is, okay, isulat ko na lang dito. Okay, chi-square test. Ang formula for chi-square, ang symbol ng chi ay ganyan. Yung parang maarte na x. Chi-square is the observed minus the expected over expected. Okay, pero dito sa taas meron siyang square. Observed minus expected over expected. O balik tayo dito sa table natin. Ang observed natin na value ay ito. Okay, itong f sub s. Kasi ito yung galing sa sample natin. Galing mismo sa data natin. Okay, this is our observed values. Ang ating expected na value, ito. Itong na-fit from the normal distribution. This is the expected. Okay? So, i-minus lang natin ito. Minus, and then square divided by the expected. Ito. So, simple lang itong formula na ito. So, let us go to Excel, and then mas madali kasing mag-compute dito sa Excel, ano? So, let us go to Excel and compute for the chi-square test. Okay? So, dito, ang gagawin natin equals observe. Okay? The observe is ito. Okay? E2 minus the expected. The expected ay ito. H2. And then, close parenthesis. At tapos, square natin. So, square. Yan, square divided by the expected. Ito yung expected natin, H2, and then enter. Okay, nandyan na yung sagot. So basically, idra-drag natin ito kasi pare-parehas naman yung formula. So dito, ito yung magma-minus. Dito, ito naman. Okay, and let us round this off to 5. Depende sa inyo, no? 4 decimal places would suffice. Pero tignan niyo dito sa first column, 0, 0 lahat. So hanggang may makita na lang tayo. Yan. 0.0003. Okay? And then we need to get the total, the sum of this one. Yan. So I can just copy this one. Ilagay ko sa PowerPoint natin. Ilagay ko doon sa PowerPoint natin. Mag-add ako ng another column dito. Okay. Palitan ko yan. 18. Alright. So, nandyan na yung ating chi-square values. Okay. Chi-square. Yan. So, we have the chi-square. And the total, galing ulit sa Excel. Okay, copy lang from Excel. Yan. Okay, so that is now my total. Ngayon, paano natin malalaman kung pasado o hindi using the chi-square? Ano lang natin. Meron kasi tayong tinatawag na critical. Okay? Chi-square critical. The critical chi-square can be solved using Excel ulit. Excel ulit yung gagamitin natin. Kasi pwede itong isolve mano-mano pero mas mabilis dito sa Excel. Okay? Ang pag-solve lang, ganito lang, ano? I-type ko dito critical chi-square. For the critical chi-square, i-type lang natin chi. Meron dyan CHISQ DIST. Okay, pero ang gagamitin natin is the right tail. Okay, ang gagamitin natin dito ay right tail. Chi-square RT. Meron tayong RT dyan. Okay, ano yung X? Okay, X is I'm sorry, hindi pala iyon, ano? Iyan, okay, sorry. Okay, so ang ano natin dito, punta lang tayo sa equals chi-square. Pero this time, punta tayo sa inverse. Chi-square, inverse, tapos dapat right-tailed. So, ayan yung gagamitin natin. Chi-square, inverse, right-tailed. Okay, kapag na-select nyo na yan, probability. So, anong probability ang gagamitin natin? In statistics, ginagamit natin na significant yung 5%. Tama? 5%. So, ang gagamitin natin dito is 0.05. 0.05 ang gagamitin. So, 0.05. The degrees of freedom naman, the degrees of freedom is eto. How many intervals do we have? Okay, there are 8 intervals, tama? 8 yung interval natin. So, the degrees of freedom is just equal to the degree to the number of intervals minus 1. Okay, mag-minus 1 tayo dito. So, 8 minus 1 is 7. So, ang gagamitin natin ay 7. So, 0.05 and then 7. And then, enter natin. So, ito na yung critical natin. 14. Napakataas, ano? 14.07. Okay, 14.07 ang ating critical. So, if we go back to our presentation, the critical is 14.07. Okay, para magamit natin itong normal na distribution natin, para magamit natin yung normal na distribution, kailangang mas maliit yung chi-square na na-compute natin kaysa doon sa critical. Okay? If, ang gamitin natin ito, if chi-square is less than the critical. Okay. So, if the chi-square is less than the critical chi-square, then this is a good fit. Yan, good fit kapag mas maliit itong chi-square na na-compute natin kaysa sa critical. So, what can you say? Ang na-compute natin na chi-square, balik tayo dito, ay 0.01637. Wala pang 1, diba? Pero ang critical natin, 14.07. So, ang conclusion natin dito, then the normal distribution is a good fit. Okay? The normal distribution is a good fit. Okay? So, yun na yung ating solution for the normal distribution. Yun na. Okay? Alright, so for this one, we are going to fit the given data using the Gumbel distribution. Okay, as you can see, I am now going to use Excel. Okay, I'm going to use Excel. And these are the formulas that we are going to use. Nandito na, no? So, ang kailangan lang natin na parameters is alpha and mu. Okay, alpha, ang kailangan ng alpha ay standard deviation. Ang kailangan ng mu is the mean and alpha. So, na-compute na natin yung mean kanina. The mean is just the average of the data. The standard deviation, we are going to use the sample formula for sample. So, makukompute na natin yung x bar and sx. Nandito na siya. Ay, parehas lang pala ito, ano? X bar and sx. Yan. Okay? Computed na yan. Yung mean and standard deviation. Okay. So, to compute for alpha, diretso na dito sa Excel, meron naman na tayong formula. So, alpha is square root of 6 times sx divided by pi. So, nandyan na yan. And then for mu, we have x bar minus 0.5772 times alpha. Okay, computed na rin yan. Okay, so kapag alam na natin yung mu and alpha, wala na tayong problema. Because itong column na to, naka-shade ngayon, parehas lang yung sa ginawa natin from the normal distribution. Okay, parehas lang yung ginawa from the normal distribution. Ang magkakaiba lang dito na sa last 3 columns natin. Okay, dito, f of x sub I, ang gagamitin natin is the Gumbel. Given naman na tayo ng formula, ito na. Itong pangalawa, f of x is equal to e raised to negative e tapos raised to negative x minus mu over alpha. So given naman na tayo ng mu and alpha, ang mag-iiba lang dito basically ay yung value ng x. At yung value ng x na yan, ang gagamitin natin ay itong upper bound. Okay, itong upper bound na to. So basically, e raised to negative x minus mu over alpha, yan na yung i-input natin dito sa formula natin dito. Okay? So, basically, ano lang, medyo mabilis lang, ano? Okay, so, example lang nito, for the first one, ito. So, we have e raised to negative e raised to, tapos negative ulit. Okay? Ang x natin is yung upper bound, that's 22.4 minus itong mu. Ang mu natin ay 35.610 and then divided by alpha. Alpha is 7.198. Pag kinumpute mo yan, we should come up with 0.0019. Okay? Gawin natin yan for all the remaining intervals and we should come up with the following. Yan na. Okay? And then, for the next one, kagaya ng ginawa natin doon sa normal distribution, to compute for the probability of x sub I, basically yan yung f of x sub I. Okay? Ang gagawin natin dyan, i-minus lang natin yung from, eto since pareha sila, kopyahin lang. Etong pangalawa, i-minus natin, okay? Minus lang natin 0.0585 minus 0.0019. So we come up with 0.0566. I-minus lang natin itong 2 previous, itong magkaano. So that's 0.2764 minus 0.0585. We come up with this one, okay? And so on. Alright? So, yun na yung f of x natin. Okay? Pwede nating palitan ito ng f of x. Hindi siya p of x. Yan. Okay? And then, kagaya ng ginawa natin sa normal, yung chi-square, observed minus expected over expected square. Ang observed natin ay ito, since this is coming from our data. Ang expected natin ito, this is coming from the Gumbel distribution. Okay, so i-subtract natin square divided by expected, we should come up with the following chi-square. Okay, and then i-add natin yung chi-square and we should tingnan nyo, pare-parehas yung critical chi-square natin. Kagaya ng pag-compute natin kanina, the critical chi-square is just the chi-square inverse, tapos right-tailed, 0.05 and then 7 yung degrees of freedom natin because we have 8 intervals minus 1. Okay, so 14.07. And then compare natin yung chi-square. Since mas maliit yung computed chi-square natin, we call it the chi-square statistics. Since this is less than the critical chi-square, the Gumbel distribution na ito, no? Gumbel. Okay, so the Gumbel distribution function is a good fit. Okay, good fit din yung Gumbel. Good fit yung ano kanina, yung normal kanina, the Gumbel is also a good fit. Alright, so that's how we do it using the Gumbel distribution.